Hi everyone, welcome to another Tech Hub training. Today we are going to be working on challenge 144 solver, which originally is done in Excel, but this time we are going to be working through it in Python. So this is the solution originally, and I am going to have us do it in parts so that we can break it down a little bit. So to start, we import pandas as PD in NumPy and SciPy. And then the first step is to load the Excel file from the challenge and read the sheet. And so this is the code that I use. You can also use OS get current working directory if you prefer that, but I set my file path as the exact file path. And then you do df.head and it'll give you the first 5 rows. And it looks good so far. Then you start to clean the data and you remove the irrelevant rows. And so you can see here we did that by saying the columns that we needed, and we get this table here that only has 3 values, so we've cleaned it up a lot. Then we extract the relevant values and ensure they are 1D arrays. And so you basically just set each of the values to what you want the column to be named. And then we get this table. Then step 3, we just define the decision variables, and we want to maximize the profit. So we do this equation, which is profit equals revenue minus cost minus commissions, and we print the profit. So that is the answer for that part. Then we set up the different constraints because in the data there are different constraints and limits that go along with the data. And so you put in the different bounds, the minimum demand, the maximum demand, the budget limit, and then you print all of these. And then step 5, you solve the optimization problem and you print the result, which is linprog, which I had to learn a little bit about that, but this is the code that applies to it. And then you print the result. And then the step 6, you display the results and you use an if statement. So if the result is a success, you print the optimal quantities, and then if it doesn't work out, you print that the optimization failed. And we see here that the optimal quantities are 500 units, 300 units, and 70 units for product 1, 2, and 3, respectively. And then the maximum profit is the 248,500.